by sketching, y is equal to cos x and okay, so we have to sketch those two on the same coordinate system and show that, okay, so I have to sketch on the same graph, right? And show, okay, we have to show that f of x is equal to cosine of x minus x cubed plus 1. Okay, so this is just, let me just sketch the xy coordinate system. So this is the y-axis. This is the x-axis. Okay, so first of all, I'm going to sketch a cosine of x. Okay. I don't know what's going on with my internet. So first I'll sketch cosine of x. So now that cosine of x, this has amplitude of 1, right? As you can see. So cosine of x starts from here. Okay, it is maximum at 0. Okay, so I'll just sketch for one time period. Okay, and then here, see, 2 pi. Here is pi over 2. Pi over 2. This is 3 pi over 2. Okay, so 1. Okay, and then it goes back here. And then the other function you need to sketch is y is equal to x cubed minus 1. So this function here, remember that if you have y is equal to x cubed, this guy just looks like this, right? Okay, now minus 1 is shifted in the y-axis, okay? 1 unit down, there's a minus here. So it means that we are shifting this curve. So instead, the y cubed minus 1 is going to look like this. Okay, x cubed minus 1. So this one here now becomes like this on the same graph. Okay. Something like this. Okay. Something like that. So this is y is equal to x cubed minus 1. Okay. Okay. So if you notice y is equal to x cubed minus 1, you can find out at what point is this curve crossing the x-axis and the y-axis, right? So along the x-axis, y is equal to 0. So if you solve for y equal to 0, you're going to have x cubed minus 1 equal to 0. So you solve for x, you see that this function crosses the x-axis at 1, right? If you take a cube root of that. Similarly, on the y-axis, you see that on the y-axis, x is equal to 0. So if you substitute x equal to 0, 0 cubed minus 1. So it crosses the y-axis at -1. So you see that, okay, on the x-axis, it cuts the x-axis at +1. Y-axis, it cuts the y-axis at -1, isn't it? Okay. So where the point where the function, okay, where these two functions meet, that is a solution, right? Okay. Where the two functions meet, that is the solution. Okay. So there is a root. Okay, that's how we show, right? Where every time the two functions meet, it means that there is a solution, isn't it? Okay, so that show that f of x is equal to 0 in some interval. So this is a point where this function f of x is equal to 0 It's because that's the point where they meet. If you get the value at that point where they meet, you substitute in this function, it's going to be 0, okay? It's going to be 0. Okay, so here, that is where the solution lies, code B. Okay, so that's how you can get that. That's the first part of the question. Okay, so these two graphs must meet as to have a solution, and they're meeting at this point. And as you can see, you can even get the range, okay? The range where P lies, okay? If you notice here, you can get this range from 1 to pi over 2, as you can see. That's the interval where P is. It's somewhere in between there, okay? So I've just picked from 1 to pi over 2. So that is the interval, in fact. You can use that interval now to do the iteration by using bisection method, okay? This function is y is equal to cosine of x, of course. So by using bisection method, you can find what this value of P is. So the interval, of course, we can just see it from the graph there, is between 1 and pi over 2. Okay. Remember, pi over 2 is 1 point something, right? So it's between 1 and 1 point, I don't know what it is. Okay, I can just divide how many times does 2 go into pi? Okay, so that is the first part of the question. Okay. And then, in fact, we've answered part B. It says using part A, find the interval where the root lies. Okay, so this is actually part B already. Okay, so as you can see, it says using the graph that you've sketched, find the interval where the root lies. So as you can see, this root lies in this interval from 1 to pi over 2. Okay, that's for part B. And then, the rest part of the question says, I use bisection method to find an appropriate value of the solution. F of x is equal to 0. So you just have to use bisection method here, and you know how to do this, right? If you have the interval, okay, so the function given to us, this function, remember, it's a combination of the two functions, right? When you equate these two equal to each other, cos x is equal to x cubed minus 1, this is what you get. You get that function, okay? Why are we equating them equal to each other? Okay, it's because they are meeting at some point, that interval. Okay, so it means that they are equal at some point. So we equate this cosine x and this cubic function. And at the point where they're equal, it's this point we're trying to find. So f of x is equal to cos x minus x cubed plus 1. Okay, now from that interval, let's check. First of all, remember, every time, don't forget, you have to check for the sign change, okay? When you are dealing with the bisection method, we check for the sign change, okay, in that interval. And you know how we do this? We test for the values, right? Okay, so we test for 1, substitute 1 in the function, and later on, we also substitute pi over 2 in the function, and then we see if there's a sign change. Okay, so we start f of 1, right? So f of 1 is equal to cosine of 1, and make sure that you calculate as in radians, please. As long as you have a trigonometric function here, cosine, tangent, or sine, you have to make sure that you use the radian mode. Okay, and then 1 cubed plus 1, right? And this is equal to cosine of 1. And what is cosine of 1?
0.540.
0.540. Okay, and this is the positive. So we're mainly interested in the sign. Okay, remember, that's what we're interested in. Okay, let me just do this, I think. Let me just share the screen, the whole screen. I'm just going to share the whole screen. Okay. Then now let's also substitute cosine. Let's also find f of pi over 2. So this is equal to cosine pi over 2 minus pi over 2 cubed plus 1. So how much is this?
Negative 2.75. Negative 2.875.
Negative. So what I'm interested in is just a sign, okay? And this is less than 0. So as you can see, there's a sign change, right? This is a positive, this is a minus. Okay, so meaning that, okay, the root exists, right? Exists in that interval. Okay, so with that information, we can now find what that root is by doing it addition. But we're not told how many iterations we're supposed to do. Are we told? No, we're not told how many iterations you're supposed to do, right? Okay. So first of all, you have to find the P naught. Okay, some says P1, it just depends if you want to start from P1 or P naught. It's okay. There's no problem. This is just naming, you're just naming the function itself. Okay, so you start, say 1 plus pi over 2, divide by that, right? Divide by 2, isn't it? So what's the, what do you get in divide the 2?
285.
1.285.
39.
39.
81.
81.
63.
63. Okay, it's okay like that. And then now we also get this function, this number, and put in the function, right? So f of that, f of 2.8, whatever, you can finish it. So this will be cosine of 1.28, whatever, minus 1.28 cubed plus 1. So how much is that?
It's negative 0.842.
Negative 0.842. Okay, and this is less than 1, this is 0, so okay, it's negative. So now we look at the interval that we had. Okay, 1 had given us a positive value. Pi over 2 had given us a negative value. So this pi over 2 now has found a replacement, another value that gives us a negative value. So it means that we'll have to update now the interval. So we're going to replace this pi over 2 with the new value that is giving us a negative, which is 1.28. So our new interval 1 to 1.28539. 8163. This is our new interval. Okay, now let's find P1. I'll call this P1. Okay, 1 plus that, divide by 2. Okay, so what is P1? So what is P1?
1.142.
1.142. I'm relying on the value that you're giving me. Okay, 1.142.
699.
699.
082. We had done this question.
Yes.
That's all.
Okay, okay. So this is our P2, and then now let's get this P2 and put in the function. So f of 1.42, whatever there, you can finish those values. Okay, and then cosine 1.4. And have you put in Canadians, right? Don't forget that. Okay, to the power 3 plus 1. So what do you get there?
Negative 0.0769.
Negative 0.0769.
51.
51. Okay.
60.
Okay, that's not necessary. Okay, since this number is not necessary, we're not going to use it anywhere. We're just trying to use it to check the sign. Okay, and of course, this is less than 0. So since we're getting negative, again, we go back to the previous interval. This is our previous interval. Now we have to update it. And from this interval, remember that 1 is still giving us the positive for this function. But now we have to replace this 1.285 that was giving us a negative, right? So we're going to replace it with a new value of P, which is 1.426. Okay. So new interval. Okay, will be equal to between 1 and 1.42699,082. And then we can get P2. Okay, what is P2? So sometimes you stop doing the iterations. If you're not told how many iterations you're supposed to do, you only stop when you get two consecutive values that are similar. Okay, that's when you stop with. Maybe you were asked to find, like, you're not told how many iterations you're supposed to do, because maybe the lecturer knows that, okay, this solution converges after some few iterations we do. So let's see if we're going to converge. Or maybe we need to do a lot of iterations for us to converge, okay? Okay, we're going to find out. So what is P2 now? We're going to add those two and divide by 2. This is 1, not, okay, there's a 1 here. 142,699,082. And then divide by 2. So what do you get as P2?
0.07.
1.07.
13.
13.
49541.
Okay, so again, now let us substitute the same in here. 1.071349,541. So this is the cosine of that. 1.07 minus 1.07. Wait a minute. Okay. 1.07 to the power 3 plus 1. So what value are you getting there?
0.249.
0.249. Okay, so it's okay.
255.
It's okay. I just need the sign here. You see that this value is greater than 0. It's positive now. So it means that from the previous interval, 1, remember that 1 was giving us a positive. So this one has to be replaced now with what? 1.0713. Okay, so this to be a new interval. So our new interval now will be 1.071349,541, comma 1.142699,082. Okay, and then you can get the value of P3. So what will be our P3? So let's get our P3.
1.1.
1.1.
070.
070.
243.
243.
12.
12. Okay, thank you. So this is the value of P3. And again, let's repeat. Let's substitute this P3 in the function given. Okay, so this will be f of P3, and our P3 is 1.107. Okay, like that. So this will be cos of 1.107 minus 1.107 to the power 3 plus 1.
0.09.
0.09.
066.
Okay, so it's okay like that. Okay, so you see that you can confirm that, okay, this is greater than 0. It's positive. Again, we go back to the previous interval, which is this one now. Okay, we change. So remember that 1.07 is the value that gave us positive value previously. So we have to replace it, right, with a new value, which is 1.107. Okay, so our new interval. So this will be our new interval. Okay, which is 1.1070 24312 to 1.142 699,082. So you see, the way we use bisection method, we are trying to reduce every iteration we do. We are trying to reduce this interval. Okay, we are trying to make it as small as possible. So we are pushing from this side, we are squeezing this interval from this side and also squeezing it from this side. So we're trying to approach that value of P we're looking for, that solution. Okay, so every time you do the iteration, you observe that the interval it keeps on reducing. Okay, remember that we previously were at 1.07, now we're at 1.10, while this one is also squeezing from this side. So we're trying to reduce this interval by this. Okay. If you're doing all right, let's go to the next iteration. So this is about P4. To try to find the rest of the values of P. See what you can do. If it converges or not. Okay. Since you're not told how many iterations you're supposed to do, so you can do as many iterations as you want. Okay. All right. But sometimes, as I said, the solution also the solution converges. Okay, find that okay, after doing a couple of iterations, you find that you keep on finding the same value all the time. The previous value is equal to the next value, and all that. That's when you stop. Okay, after that, I want to sketch here. Hello. Able to see the last screen that I'm sharing here now?
Yes.
Y is equal to x. Cos x. And also another one, y is equal to x cubed, right? So you see that where those two guys are meeting, right? Okay, x cubed minus 1. So as you can see, this is what I said. Okay. So have you seen where these two functions are meeting, right? So you see, this guy here, this one here, the one I sketched, I think I showed you. This is y is equal to x cubed minus 1. It's crossing the x-axis at 1. And then the constant function crosses the x-axis at what? Pi over 2. So pi over 2 is that number in decimals, which is 1.5 something, right? Okay, and then where they're meeting, see where they're meeting is, that's where the solution may just zoom it in. See where they're meeting, look at the value of x. What value of x are you supposed to have there? Which is about 1.13 somewhere there. So if you are doing that, when you are doing iteration, try to confirm that you're approaching that value of about 1.13 somewhere there. This is the value of x. So that is the solution that you need. It is clear.
Yes.
Okay.
Yes, sir.
Yeah. So if you want, can sketch it on its own. We are given it as what? It was cos x minus x cubed. In fact, sketch just one function if you wish. Plus 1.
I have a question.
Yes, please.
Like the way we did previously, where we had that quick check for epsilon where there was relative error. Can we use it for this?
Oh, this one we can't use it because we are not told about the relative error for this function.
Oh, okay.
So we can't tell how many iterations you're supposed to do. You won't do that when you're told the relative error. Okay?
All right.
Yes, yes. So you can see that the next question, number 4, says to find the bound for the number of iterations. That's question number 4. Let me quickly do it before we run out of time. We have about 6 minutes left. Question 4, just do one part, and you can do the rest just like that. Remember, for question 4, you don't have to use the function. Okay, the function is not necessary. What you need for you to check how many iterations you're supposed to do is just the error given, and also the what? The what? The interval that is provided to you. Okay. So find the bound for the number of iterations needed to achieve an approximate to an accuracy of part 1 of 10 to the power negative 4. So this is called 4 significant figures. Oh, at least I've learned something. Oh, 4 decimal places. You remember last time I said I need to find out how you handle it with given decimal places, right? So actually this question is has gain me leakage. Here, there is this part I said the first question we solved last time. Where is it? Okay, here we are supposed to approximate this function to 3 significant figures and 3 decimal places. So if it's a decimal place, this value here is not 5, it's supposed to be 10 to the power something. 10 to the power, the number of decimal places mentioned, negative decimal places. Are you getting the difference? If it's significant figures, it will be 5. You're using 5 times 10 to the power, okay, times 10 to the power negative number of whatever mentioned. Is this okay? So if the question says approximate to whatever decimal places,
Can you repeat that?
if the question says approximate to what decimal places, you have to use base 10, right? The base has to be 10, 10 to the power negative whatever number of decimal places you are taught, t. So t means decimal places. If the question says, oh, approximate this function to what number of significant figures, so you have to use this one, 5 times 10 to the power negative whatever significant figure. This is the error that you're supposed to check all the times you're doing the iteration. And I showed you last time how you check this error, okay? By doing the iteration, subtract the previous minus the present, the present minus the previous divided by the present value, right? Okay, this is exactly what we're doing last time here. When you're checking the error here, where is it? Here. This is how we're doing it, right? Last time. So this one we're using 5 significant figures. Sorry, 3 significant figures, which is 5 times 10 to the power negative 3. This is 5 times 10 to the power negative 3 here. But here we're talking about decimal places, this question, where we were given both decimal places and significant figures. So for the first part says to 4 significant figures, so 4 decimal places, this one. So what you need to do is just to use this rule, which says that, so this is the power negative 4, b minus a over 2 to the power n should be less or equal to whatever error given, epsilon, okay? So here our epsilon given is 10 to the power negative 4. And then for the first question, question A, we're only interested in the interval, not the equation. So the interval is, how many minutes am I doing? About 2 minutes. Oh. So the interval is 1 to 4. So B is equal to 4, A is equal to 1, right? So this will be 4 minus 1 over 2 to the power n less or equal to 10 to the power negative 4. So you have 3 over 2 to the power n less or equal to 10 to the power negative 4. So this one here, you can take 2 to the power n on top. This come to the power negative n less or equal to 10 to the power negative 4. And you can divide both sides by 3, just mean it's 2 to the power negative n. Let's equal to 10 to the power negative 4 over 3. Okay, so for you to solve for n, just introduce natural log of both sides. Okay, I think I showed you last time. Okay, do natural log both sides. You drop n, you have negative n, natural log of 2. So the time is up. Okay, and then also find natural log of this guy. And then you divide by negative, you see that n will be greater than or equal to natural log of whatever here you have. The power negative 4 over 3 divided by natural log of 2. So this will be the value of n. So you do the same thing for the other values, for the other questions as well. Okay. So where it says 4 significant figures, you just have to put what? 5 times 10 to the negative 4. That's it. And then you do the same iteration. Time is up.